In this video, we're going to cover questions 11, 12, 13, and 14. All of them, I think two of them will require synthetic division. This first one right here just basically says this is question 11. And in this question, we want to identify all three real zeros of f of x, okay? Now, this one, you can't really use synthetic division because there's no p, there's no constant on the end. But it is solvable because it has an x in every term. We can factor out an x. So that's the first thing that we're going to do, is we're going to factor out an x. So we're going to say that f of x is equal to, we're going to divide one x out of this, and an x out of this, and one x out of this. So we're basically taking out the greatest common factor. So we're going to make an x, then we're going to open a parenthesis, and x to the third divided by x is x squared. And then negative 7x squared divided by x is negative 7x, and then negative 18x divided by x is just negative 18. Okay? And so what we now have is we factored out an x, so that's going to give us one of our zeros, and then the other two zeros are going to come from in here. And you can see there are 1, 2, 3 x's, three real zeros. Okay? Now this one is a quadratic. We have an x squared, so we can either do the quadratic formula on this, or we can factor it if it's factorable. So are there two numbers that when you multiply them together, you get negative 18, and when you add them together, you get negative 7. There are. Those two numbers are negative 9 and positive 2, because negative 9 times 2 is negative 18, and negative 9 plus 2 is negative 7, okay? And so we can actually factor this into, we have x, and then we have two factors. We're going to put an x here and an x here, and our two numbers are negative 9 and positive 2. And so now what we've done is we factored f of x, and if we want to find the real zeros, we have to set this equal to 0 and solve. Well, to solve this, all we have to do is take each of the three factors and set each one equal to 0. So we'll have x is equal to 0, x minus 9 is equal to 0, and x plus 2 is equal to 0. Well, this one is already solved. X is equal to 0, so that's actually one of our real zeros, is 0. This one has to be solved. We have to solve for x. So we're going to add 9, and we get x is equal to 9. So x equals 9. And then this one has to be solved. We subtract 2, so we have x is equal to negative 2. And so that's our third zero. And so we have identified all three real zeros of this function f of x. Okay, let's look at question number 12. It says to use synthetic division to get the quotient and the remainder. And we're going to write the quotient down here and the remainder over here. The quotient is going to be a polynomial, and the remainder is just going to be a number. Okay? And so we're going to use synthetic division to divide f of x. F of x is this third power polynomial, and we're dividing it by g of x, which is x plus 4. Okay? So to use synthetic division, we're going to go to our divisor, x plus 4, and we want to do the opposite of plus, which is minus, and we want to do the number 4. So we're going to put negative 4 into the half box. Then we're going to take the coefficients of the dividend, and that's going to be 7, 24, negative 13, and 4. And so we're going to put them across the top, 7, 24, negative 13, and 4. And then we're going to draw a line, and we're going to leave some space right here so we can write some numbers, and we're going to have some numbers that are right down here, okay? Now, if you have not done a lot of synthetic division, you're going to need to practice it. Go back to one of the videos on synthetic division and do a lot of synthetic division. This review is not really the place to try and practice synthetic division. By the time you get to this review, you should already know very well how to do synthetic division. So if you don't, then I encourage you, go back to the lesson where we learn synthetic division and spend a lot of time on that lesson, okay? All right, so we're going to carry down the 7 under the line. 7 times negative 4 is negative 28. Negative 28 plus 24 is negative 4. Negative 4 times negative 4 is 16. 16 plus negative 13 is 3. 3 times negative 4 is negative 12, and negative 12 plus 4 is negative 8. And that is our remainder. Our remainder is right here, negative 8. So down here, we're just going to write negative 8. That's our remainder. And then our quotient is going to come from these numbers at the bottom. We started with an x to the 3rd power, and therefore this is going to be x to the 2nd power. So we're going to have 7x squared minus 4x, positive 3 means plus 3. And so this is our quotient, 7x squared minus 4x plus 3. All right, now let's look at question number 13. It says use the remainder theorem to evaluate f of 2 and f of 4. We actually did this in questions 4 and 5. If you go back and look at the videos for questions 4 and 5, we did exactly this. We used the remainder theorem to evaluate, I think it was like, f of 3 and f of 5 or something like that in a piecewise function. To use the remainder theorem, we typically use synthetic division. And what we'll do is we're going to take the number that we're evaluating, 2, and we're going to put that number in a half box. Then we're going to take our polynomial that we're plugging the 2 into, and we're going to write the numbers out right here. So we need a 3, a negative 21, a 21, and a 45. So 3, negative 21, 21, and 45. And then we'll draw our line, and we'll have some numbers here, and we'll have some numbers here. But we actually don't care about the numbers here. For the remainder theorem to evaluate a number within a function, we really just care about the remainder. Whatever the remainder is, that's going to be our answer, okay? And so let's go ahead and do our synthetic division. We'll bring down the 3. 3 times 2 is 6. 6 plus negative 21 is negative 15. Negative 15 times 2 is negative 30. Negative 30 plus 21 is negative 9. Negative 9 times 2 is negative 18. Negative 18 plus 45 is 27. And therefore, our remainder is 27. And therefore, f of 2 is equal to 27. Okay? Now we're going to do the same thing for f of 4. We're going to put a 4 in the half box. We'll do that over here. 4. We'll use the same numbers. 3, negative 21, 21, and 45. We're going to draw a line. Bring down the 3. 3 times 4 is 12. 12 plus negative 21 is negative 9. Negative 9 times 4 is negative 36. Negative 36 plus 21 is negative 15. Negative 15 times 4 is negative 60. And negative 60 times, or plus 45 is negative 15. And that's a remainder, therefore f of 4 is equal to negative 15. Now I know I do this fast. I have really good mental math. I mean, I'm a math teacher, right? If you don't have, if you can't do negative 21 plus 12 in your head, then go ahead, make sure you're using a calculator and make sure you key it in, negative 21 plus 12, plus 12, and it'll give you your negative 9. And if you do your 21, you can do 21 plus negative 36, or you can just do 21 minus 36. It's the same thing, okay? But this is how we use the remainder theorem to evaluate the output of a function at a value. Okay, question 14 says circle only factors of this. Okay, and what it's saying is that one or more of these factors, these binomial factors, right? X minus 2, x plus 2, x minus 3, x plus 3, okay, can be factors of this polynomial. And one of the ways that we find out whether a number is a factor of a polynomial is with synthetic division. Now this polynomial is a fourth degree polynomial. Therefore, it can have up to 4 factors. So it's possible that all 4 of these are factors. That could be true. It's unlikely, but it could be true. The way we test a factor, so we're going to test x minus 2, and the way we test it is we're going to divide y, this function, this polynomial, we're going to divide it by x minus 2. So we're going to put the opposite of negative 2 in a half box. So we're just going to put a 2 in the half box. Then we're going to put the numbers, the coefficients, 5, negative 2, negative 32, negative 19, and negative 6. So we'll have 5, negative 2, negative 32, negative 19, and negative 6. I'm trying to conserve space because I have to do 4 of these. I have to do a separate synthetic division for this one, for this one, for this one, for this one, and I want to fit them all in this space. Okay? All right, so bring down the 5. 5 times 2 is 10. 10 minus 2, or plus negative 2 is 8. 8 times 2 is 16. 16 plus negative 32 is negative 16. Negative 16 times 2 is negative 32. Negative 32 plus negative 19 is negative 51. Negative 51 times 2 is negative 102. And negative 102 plus negative 6 is negative 108. Okay? And so the way that you know that this is a factor of this is if the remainder equals 0. But this remainder does not equal 0. And therefore, this is not a factor of this polynomial. So this is not a factor. We're not going to cross it out. We're just not going to circle it. Okay? Now we're going to try x plus 2. So that means we have to do the opposite of plus 2. We have to do negative 2. So I'll put a negative 2 in the half box, and I'm going to use the same numbers. I'm going to do a 5, a negative 2, a negative 32, a negative 19, and a negative 6. Then I'm going to draw my line. I'm going to bring down the 5. So 5 times negative 2 is negative 10. Negative 10 plus negative 2 is negative 12. Negative 12 times negative 2 is positive 24. Positive 24 plus negative 32 is negative 8. Negative 8 times negative 2 is positive 16. Positive 16 plus negative 19 is negative 3. Negative 3 times negative 2 is positive 6. And negative 6 plus positive 6 is 0. So we have a remainder of 0. That means that x plus 2 is a factor of 5x to the 4th, minus 2x to the 3rd, minus 32, etc., etc. Now we're going to test x minus 3. So we're going to do the opposite of negative 3, which is positive 3. We're going to put that in the half box. And then we're going to do our numbers 5, negative 2, negative 32, negative 19, and negative 6. Draw a line. We're going to bring down the 5. 5 times 3 is 15. 15 minus 2 is 13. 13 times 3 is 39. 39 minus 32 is 7. 7 times 3 is 21. 21 plus negative 19 is 2. And 2 times 3 is 6. 6 plus negative 6 is 0. And so we got a remainder of 0 again, and that means x minus 3 is a factor of that polynomial. Now we just have to test x plus 3. And so we have plus 3 here, so we're going to switch that to negative 3. So we're going to put a negative 3 in the half box. We're going to do a 5. We're going to do a negative 2. We're going to do a negative 32. We're going to do a negative 19. And we're going to do a negative 6. Draw a line. Bring down the 5. 5 times negative 3 is negative 15. Negative 15 minus 2 is negative 17. Negative 17 times negative 3 is positive 51. 51 and negative 32 is 19. 19 times negative 3 is negative 57. Negative 57 plus negative 19 is negative 76. Negative 76 times negative 3, I'm going to need a second for this one, it's positive 228. Positive 228. and 228 plus negative 6 is 222. Our remainder is not 0, and therefore this is not a factor. And therefore, our only two factors of these four numbers, the only ones that are factors of this polynomial, are x plus 2 and x minus 3, and we are done.